But if your Jupyter notebook does not start, you have to go and watch other videos, or I can just show you. Just click on this terminal, click on the terminal, a terminal will be open. So you just open a new terminal. Once the terminal opens, all you have to do is do the pip install, pip install, pip install, pandas, matplot, all this. So I'll be putting all this installments or the dependency in the description, so don't worry if you are new to this channel, but it will be best off if you subscribe to the channel so that you support the channel and the dream of making this channel a better place for all programmers, and also for beginners especially who want to learn machine learning, become a reality, and also become some professionals as well. So better off, let me click this cancel and start off with the project. So we start with importing some basic libraries from sklearn. So first we take from sklearn. Our most important thing, that is we import the data sets, which is very important. We also take okay, let's import the pandas. We install the pandas, imports as what, PD. So these are the two basic things I think we need it right now. We also be converting the data set into a data frame for beautiful visualization, right? So that we see the columns, see the rows, and also the data set will be from the iris data set. So when you are done with everything, you just shift enter and it runs, right? So once we've once the sklearn data set and the pandas is initialized or are being imported into our system, we can now start loading the data set. As usual, what we do, we use comments a lot here because we want our programmers to understand what is going on. So we load the data sets, or let me say the iris data sets here. So how do we load it? It's very easy. So what you do is call this data, then we equal to sign, and do what? We write the data sets there, and once you write a data set there, we do just a dot, and a lot of data sets available comes. So what do you want to load? We want to load the iris, load iris. Once you have the system installed, that is the Anaconda and the basic tools installed, you can get these data sets. So I've already covered a lot of videos on how to install Anaconda, how to start your set up your Python to understand machine learning algorithms. I have all the videos there, so you can check on the channel. It's a good channel. So once you've done this, you do a shift enter and it loads. So what does it mean? This means that we now have the data set in the data, right? So we can write data and call the data. You see that we have a lot of data, right? So you can see we have a lot of data here, but this data is not very visualized. It's very difficult for you to understand. Okay, we know that we have arrays, we have 5.1, we have a lot of things here, but what does it mean? You don't really understand what is going on, right? Because it's messed up. So what you do, that's where we use the data frame, right? So a data frame is just a rows and a column, kind of a table format of the main data. So what you do PD, then you come to PD, that is the pandas, then you do the data frame, yeah. And once you have the data frame, we have data, right? We have the data, accepting data column, and what do you accept? You accept the data here. And the data, we accepting what is the main data here. So our main data here is the data I'm getting from the pandas. So the data we're getting from what? So when you call this data, we have this data here, and a lot of data were there, right? So you can see here. So we can pick that data here, and our next step will be what? Initializing some columns, because we want rows and columns, and we want the columns to have the feature names. As machine learning, we usually use a easy understandable words or labels to structure our system variables, because as the data becomes so large, it becomes so difficult for you to understand what's going on. So the best thing is to use some labels that are already defined. They define the data sets you're collecting. So we initialize a column. So we have a column. We have a column here. So we have columns. right, the columns here. So we have the columns, and we are going to take the data. And what data are we looking for? We are looking for the features column because these are the label names, right? And we shift enter. So is it the outputs collapsed? Why is the output collapsed? The output collapsed because pandas does not recognize this name there. So the name has to be pd dot data frame with a capital F, right? And once we are done with this, we now have the data frame, we have the data there, then we can call the data frame here, and it's a work because now we have the the sepal length, we have the sepal weight, we have the petal weight. So let me give you a general idea about what the data set actually means. So this data set is nothing but a flower, right? So we have different species of flowers. We have the vetosa, we have the setosa, you have the versicolor, and you have the virginica. So these are the three species of flowers that we have, and based on these three species of flowers, we want to create a system that in the case we enter some components, let's say the sepal length, we enter 5.1, and we have a sepal weight of 3.5, we have petal length of 1.4 and 2.0, right? This data that we've input should predict what is it, a versicolor, is it a setosa, or a petal, so a virginica. So the main idea of this project is to help us understand the basic prediction, right? How to classify our data, how to know that this data, when we enter something about this data, we are going to get this. When we enter something below, we are going to get this. So the main ideology of this project is to help we classify and also make some predictions. Good. So once we understand these projects, or once we understand these pictures names, we can proceed by targeting, right? So every classifier or every classification deals with what a target. So the target, also known as what class, these are the conclusive or the predictive data that we deem to what obtain, right? So this data, based on this data that we obtain, we can now say that it's a versicolor, is this, is that, right? Hope you understand. So we now target our data sets, we target our data frame, and we target, let's name them species, right? Because we have only 3 species here in the data frame, and we target our data. Our data has a main target there, and once this is correct, we can now call our data frame again, and you see that the data frame now has what this species there, which is 0 0 0 0 1 2 2 2. So what does this mean? This means something. It means a tosa versicolor, but you don't understand because now it's 0 0 1 is kind of not it's not explaining itself, right? It's not explaining itself. So to add some explanation to it, we are going to do what? We are going to map over every species data set that we have, right? All the species data set that we have, and we are going to change or convert every 0 to setosa, every 1 to versicolor, every 2 to what virginica, to make it understandable. I hope it makes sense, right? Good. So how do we do this? We do this by it's quite easy. So let's comment as we normally do. So we converting all the species names or species data to something logical or explanatory. That is into brackets. We have the setosa, we have the versicolor, we also have the virginica, right? Virginica. So we go, this is how we do it. We go to our data frame again. Our data frame, we target the species, because once we update the species, right? And once we want to update the species, we want to map over every species that we have. So we go to data frame again, then we go target the species. You can see species coming from there, and we are going to go map over them. What does the map do? So if you've learned data structures, I'll be working on a data structures project or tutorials. So data structures, using map map do what it targets all the indexes, and is a kind of a for loop, right? But this is an abstract data type which runs all the indexes and pick every index and their respective what data, right? So every index and their respective data is like a for loop whereby you write a for I score to 0, I plus plus, and I, and based on the I word becomes the index, right? So it runs a loop or iterative loops, right? So now our main target is what, 0. We have 0 there. You can see 0 here. So we have 0 here. We have 2, 1 there. 1 is somewhere there. If I call the data set, you see, we have 150 columns by 5 columns. 1, 2, 3, 4, 5 columns. We have 150 data because it started from 0, so it's 150, 149 here. So 1 is in between there, and we want our 0 to what? Setosa, and we want our 1 to be what? A basic color, right? We want our 1 to be a basic color, and we want our 2 to be a Virginica. Hope the spelling is correct. So once is intuitive, we can write down data frame. We can call the data frame again, and we expect that once you run the data frame, the species to change. The species section must have a data called the setosa, the versicolor for all ones, the virginica. So we can shift enter, and now we have the setosa, the virginica. So this is it's explanatory now. We can now understand the data set very well, even though we have not made any predictions, we have not made any learning. So our next step will be what? Our next step is trying to groom our data set, pick our relevant data set and the y values, and based on this x data and the y values that we get, we train them, right? Once you train the data set, you can learn the train data set and make predictions. Hope that makes sense. So for the purposes of this project, we'll be only targeting 2 components. That's, we will target either the sepal length, the sepal weight, or the petal weight, and also the target. So based on the sepal length that we enter, we must get a corresponding species or the outcome. Hope it makes sense. So let's go to comments again. So we now group our data sets into the x and y values. What does it mean? It means the s component, that is the dependent, or the s component, that is the dependent or the predictive, right, is going to help to give a response. Good. So the x data, we select what do we select? We select the data frame, and I would like to use the sepal length or the sepal weight or the petal weight. So let's use one. So let's use the sepal weight centimeter. Please enter the same name as it is here. So we are picking this column. And the reason why I brought 2 arrays is because we're writing a 2-dimensional data, right? So that is the x1, x2, like the linear regression method where it takes y is equal to mx plus c, and the x component is there, and based on the s component, we are going to use that one to predict what the y response. Hope it makes sense. You get understanding as we move further. And also the y components now will be what? The data frame, as we all know, is just the species, right? So we just pick the species there. Now once we have our data sets available and we know what you're working with, we just shift enter and it takes. So when we got into, we are now come to a train. I know you've waited for long. I want to make this video as short as possible because long videos are kind of intimidating to watch, right? So the next step will be training on data sets, right? So we're going to train our data sets into a train and test data, or better still, you can say we are splitting our data sets, what's a training and a test data set. So how do we do this? We do this by first importing some libraries, and the libraries are going to help you to our data set very well, so that our data set will not be like they don't know what they are doing, they are just moving around. So we go by going from scikit-learn. If you're using scikit-learn a lot, but you can use TensorFlow if you have TensorFlow, and we just pick the model dot model as selection. And which model selection do we want? We want to import a train test plate data So we shift enter again. Then we now have the train test split data there. So we do what? We start with the initializing our data sets or our targets. Our target that is the species target, and the S data inputs, right? That is the sepal length. I have to put here so that you get understanding sepal width. Or better still, we can just change this one there to make our data more understandable. I like to keep data understandable. So X train, as usual, X train, Y text, right? Then we do the Y train underscore tree, and we also test the Y data, right? Okay, good. And so we call it a text train. And what do we expect? You say expect an arrays, right? You expect an array, a text set, a text size. Also the text size can be float, can be none, can be, and also we need a random state, and the random state can be a number, it can be nothing. We can also do a shuffle whereby every time we run a data set, we are going to shuffle the data like randomly, and can also do a stratify like an array like we want. So I'll be just leveraging on the only three data here. So the first one will be our X data and our Y. These are the two data sets you'll be using for the predictive analysis, right? And our next one will be the text size, which as we all know, our text size must be a little bit of quantity compared to the trained data. So we use a small sample size for the test data, and so 0.2. Okay, let me use 0.2, that's 20%. And the random state, that is 42. That is, it runs randomly 42 times, right? So the random states can be ready here. Instance of non-data. Control the shuffling applied to the data before applying the split. So the shuffling is 42 times, control set 42 times before applying what the split to it. So once we initializing our data sets and our targets and our input, we just shift enter and it runs. So we now have what? A train data set. We have the X text, we have the Y. So we can test by doing the X train to see what is there, even though it's quite not relevant. Yeah. So after our data set has been trained, we saw that we have this index 22 having a 3.6. These are the data sets that contains the 80% data that we have. So you can see we now have what 120 out of the 115 we are there. Our data set was taking only 120, that's 80% of the data set, and it's being reshuffled. It didn't start from 0, but it's randomly did 22, 15, based on the indexes, right? Good. So since we have all this understanding, what's the next step? The next step is obviously what's training a model, because we train the data set, and after training the data set, you have to train the data set with a model so that the model will understand what you are doing. So we can create a MacBook here. So we create a MacBook here. Oh, come on. I'm sorry. We create a MacBook here, and a MacBook, you just shift and just write something. So here we training our model. What other people call it, like classifiers, classifier, and learn our new data set, learn our trained data sets, right? Good. So learn our trained data sets. So shift enter and become so big. So what is the objective? We are going to train our model, right? Train our model or classifier and learn our trained data set to what make some predictions, right? So we can add it and make what predictions and make predictions. That's good. And make predictions. So we have this concept there. What I'm going to do, we just go to scikit-learn. We go to scikit-learn. So let me pull the cap up. So we go to scikit-learn. That is from sklearn. What are you looking for? We're using lots of data sets, so I'll cover them in a playlist form. I'll analyze, but the first thing I'll analyze is the linear one, which is quite easier to understand. So do linear model. Then we import the logistic regression, right? So the logistic regression is like it's a model, right? That is mean that helps me to do some mathematical concepts like the nearest neighbor, the support vector classifiers, machine learning. So this logistic regression help you to undertake or underperform some predictions by understanding some distances between the two data, and it purposely is a model that is going to make our life so easy by helping us to limit writing some logics, like plenty logics whereby you take the data, you have to write the formula and do this, but this already have the formula there, so we just leverage on that and do our WhatsApp prediction. So we shift enter, and once we shift enter, we then can start with what the training. How do you start with the training of our model? It's very easy. So we have the model here, so let's name this one model. Then we just do the logistic regression, then call it this way. So once we call, we just shift enter. Now the model is going to what's learn. So let me push this one here. So now model is going to learn the train datasets. So what are the train dataset? That is the X train and also the Y what underscore train. Good. So these are the two main datasets that we learned or that we trained. So we come here, we do a model dot fit. So whenever you see fit in machine learning, it means what we are learning something. We are learning something new. So fit, you are fitting, right? And you are fitting what X train. You are fitting X train, and you are fitting what the Y train as well. So these are the data. So once we shift enter, it's going to take a little bit long pertaining to how fast your CPU is running, or how frequently you run your data sets, or you train your logistic regression with your machine. So once the classifier has been linked, so we now have the classifier linked. Now we can do some predictions, right? You can do some predictions, but even though this prediction is not that accurate, we can even do some predictions here because you have the model, right? The model knows the data, so you can do like a model. So let's make predictions, right? So let me come here. Based on this model, or this and this one, let's write a markdown. So make predictions here. So making the predictions. How do you make the predictions? It's very easy. Like that is the most easiest part. Like predict, white predict, right? Because we want a response, and based on white predict, what do we want? We want something very easy. Good. So we do the model. We already have the model. So and we do what dots. And a lot of generative methods have been called here, but we want to predict. We want to predict only. Then what do we want to predict? We want to predict our X text with the model. So if our model really understands what is going on, and we're saying that our trained data set is having this one, our X train is having this, and now you say that model, please learn it. Wants you to bring something, learn the train data sets here. After learning it, since you understand what is going on, please model, take this X text, that's the 20% data you have, and make some predictions so that we see your accuracy level, right? So we can test it by doing y_predict here, and shift enter. So you can see that we have a lot of data sets here. That's the Vertosa, versicolor, and from here we can see we have okay, so I didn't call the actual data, but it's good. You can just text here by doing y_predict or y_train. So our y_train here is also Vertosa, Vertosa versicolor, and our model is also predicting something this. So this is our prediction, right? Our model prediction, and this is our training data. But our model is what testing using the X test. So equally, if you are going to use something to analyze our data or compare our data, then it should be the Y test, right? Because you're using X test to predict. So we predicted, and our model gave us this data. Good. Now, since we want to see some comparison between the Y test and the X test, we have to train the S test, and based on the S test, we get a prediction. Good. Now we have this, so we can now do the Y test to see the equivalence data, and we compare. So you can see it from here that we have first one to be a versicolor, and our prediction is also a versicolor. We had a Setosa Virginica, but it predicted this thing wrong. So there's a precision wrong here. There's a precision, or the accuracy level here is that low, because even at the first two at the first three predictions. He had only two correct in the first one, but as it continues, it start building up. It start building up, building up, and it did the last one to be 30. That is Setosa, but we haven't been in. So how do we test if our model really is a good model, and we can then save the model so that we can start writing some codes? How do we do this? So we built on some metrics, right? We leverage on some metrics that are is in machine learning, right? So these metrics are, so let me start by doing this. So we find the metrics of our model to make some conclusions, to make conclusive decisions, like saving the model or not. You can also do some or not. Sorry if I'm typing wrongly. So let's say this is our main idea. We want to make some metrics, want to find a metric so that we know if our model is that strong or the model is not that, or want to know if the model is strong or not. So this is quite easy. So we do from the cell the sklearn. What do you want? You want our metrics, right? So dots, we pick the metrics there and we import some basic metrics like the accuracy, ACCU, accuracy score. We pick the classifier reports, and we also pick the confusion metrics. These are the common metrics that we use in programming or in data sets. So I can just delete this one so that we run the code step by step. So these metrics are there, but before we can use the metrics, we need to understand something. We need to understand some basic necessities of these metrics. So these metrics, we have the precision, we have the record, we have the support, we have the average layout there. We have some basic concepts like the way when you call the predictions on the describe, when you call predictions on this one, where the data set. So when you call predictions on a data sets, right? So this data like this, as we read the data, oh come on. So we're moving up. Okay, so like this data that we had, if we really want to understand the data, like some basic data from here, we can do like a data frame, dot head to understand the dot describe, so that we get to see some basic parts of the database. So when you do describe, you see that we have counts, we have mean, we have standard deviation, we have the mean 25%, and all these data sets are available, right? So these are the common. So you can see that when you describe the data, we have the standard deviation, we have the mean, we have the count, we have the percentile, that 25%, the 50%, the 75%, and also the maximum, the mean, and the maximum. This can be used to draw some box plot, so that we analyze the data very well on a visual scale. And so that is the main motives. Like this is a metric to the data, right? But in classification, when you classify, when you train a model, you can also pick some matrices from there, right? So how do you pick these metrics? That's the accuracy score, which determines how accurate our data is predicting the model, how our model is predicting the data. Sorry, the classification reports that brings some ideology about the data, like the precision, the recall. So I'll later explain it in another subsequent videos about the record, the precisions, the average, support, all these things. You see them here, but I'll not really go into it because the main idea is to help we understand. The main idea is to help we understand how to predict, how to learn in data, to get a vibe, and later proceed into some well detailed projects. Good. So we do this prediction by very easy. So accuracy, we start with a variable name called accuracy, accuracy. Accuracy to my typing is kind of frustrating me right now. And very easy, another accuracy again, accuracy score. Then the accuracy score, you see that we have the y value there, we have the predictions, we have the array, we have the boolean, we have and the weight. So these are the arguments of accuracy. So from here, the y values are quite prevalent. They are they are the interest, right? So we do the white predict because we want our prediction. We're comparing two data set. That's two responses. That's the prediction and also the white test, right? And the white test. So once our accuracy level is so high, then it means our model really understand the data, trained on the data, learn the data very well, and the accuracy level, the predictions based on every constituent or data that was scored, the model was kind of close to the actual data that it learns. So after prediction, after training the data, we check the accuracy. It's good off to check these metrics so that you can, as suggested, you can save the model or not, or you can just forget that one. So shift enter, and now we test our accuracy by doing ACCURCY, then boom. So we know that now our accuracy is just a 60%, which is, in machine learning, is good because machine learning we normally accept something above 0.5, then it's a good model, right? So if our model is able to give an accuracy of 0.6 is good, right? Good. But we can moreover work on this accuracy, training with a lot of data sets, or like marginalize it, normalize, check how distributed the data is, and do some standard scaling, normalization as well, do some feature extraction, dropping some duplicated data to really make the best of prediction. Also, once the predictions are good, the accuracy will be very good. So we now done with the accuracy. We can also change the classification reports and then subjects. It gives a well-defined. I like using the classification report because it gives the well-defined. It's actually contains the accuracy. It contains the confusing metrics, that is the precision, the recalls. So how to use the classification report is very easy. So CLF. So I love to name it. So CLF report. CLF report. Then we go this way by doing a PDF, or we can convert it to a data frame. Likewise, so but the basic level should be that. So we can convert into a PDF, but the basic level will be whereby we put the classification report it there, and based on the classification report that we have, what we do, we pick the white predict and the white predict, like the white prediction, the white text, and we need something called the output dictionary, right? The output dictionary way to leverage or transpose our data into a data frame, or convert our data into a data frame. I hope it makes sense, because we already understand how data frame works. Data frame gives us the table format for visualizing, say. So we can do the output data frame output, then we set that one to true so that we can convert it to a data frame. Now once we have this, let's shift enter, and then we can do CLF again, CLF reports. We can do a equal sign, then a PD dot the data frame. Now we can call a CLF reports, yeah, and call that one there. Now CLF reports here. When you call, you see that it's this way, but the Anaconda is kind of it's a two-side precision, but we want the columns here, that the first column should be transposed, right? So using basic mathematics transposition, we can do CLF dot transpose here, sorry, dot transpose, and once we transpose it, it's kind of interesting to read and analyze, because we want to make everything easy to understand. So you can see from here we are having an accuracy of 0.6, as the accuracy was here 0.6. We are having a precision, which is the number of correct predictions the model make out of whatever we give it, and the recall is the number of prediction, the number of correct prediction the model at its correct form, what we want to get. I'll later explain this in the next video, but this is what the database or the data or this tutorial is about. So we can also do this by looking at the visual aspect. So let's do a visual aspect. So we now check the visual data frame. I'm a data frame. So very easy. As always, I say it's very easy because you have to make it easy for yourself to understand. So matplot book, you do the matplot, right? So the matplots help you to plots, as in the name suggests, so plots, pie plots, as what plt, and we import the seaborn, which help you to visualize or draw some quantitative data data sketches or illustrations by the histogram, the box plots, the line curve. Yeah, so this is going to help you to do this as what SNS. So the first thing, we call them, and once they load, once it's done with the loading, then we can now start with what analyzing our data sets. But our data set was specifically done for our data set was set for this separ weight, right? This separ weight that we have. So this separ weight, this is what our data set was about. So we just come here to this side and we do this very easy. Once again, we can say the box plot or X or separ plots. So several box plots, then we do SNS dot. What are we doing? We are looking for a box plot, right? So a box plot, what the data, right? The data source that we need the X data, right? We need only this X data there to draw the box plot. It's quite easy. So we shift enter. Once we shift enter, it runs, and the box plots will be drawn. And what is this S value? This S value represents the separ weight. So we can just pick the X value here because I don't want to be going back. So let's understand the X value here. And you know our X value is the separ weight, that is 3.5, 0.5. So you can see our data set is the highest value here. The highest value is somewhere around 4.4 something, and this is our highest quartile, our median, and our lower quartile, right? We have some outliers. These outliers, when we do the standardization, when we normalize our data very well, these outliers are deemed to be reduced based on how normalize our data. We normalize our data sets so that our data sets what we can make some predictions very easy. So check out on the next video, that is the analyzing or normalizing our data sets. So this data set that we have is, as I suggest, so we can also do something special here by doing x dot doing the describe to check what is going on. If we don't really understand what is going on, so you can check the maximum is 4.4 as you suggest. So 4.4 there. We have the count, so that is the number of times data, or the number of data we have, that is 150 data. We have the mean. As you all know, the mean is what we add everything and divide by the total frequency. We do the standard deviation, that is the x minus the each component data, then we divide by the total component to find the standard deviation. We can also find the variance, find the square root of it, the minimum. So the minimum is just 2.0, that is the outlier, and we have the 25 percentile, that is this one, finding itself at 2.8 here, 2.8, that is, no, this is the percentile, right? So 2.8 there, and we have the 50%, that is the median, find out 3, and we have the 75 percentile, finding out this side. So these are the whiskers, this is the plot itself, and these are the outliers. So the box plots help you to visualize the data. So I'll cover in my next video, I'll be covering on the normalization and see how best we can train our data sets, or we can manipulate our data sets to have the good accuracy, something better than the 0.6, and also tackle a new not regression, but we'll be doing the k-nearest neighbor. We can also do, you didn't check on the confusion matrix, but we'll do it on the next one. In the next one, we also do the we'll do the support vector classifiers as well. It's very important. So thank you for watching the video, and I think this video will help you guys to analyze and understand this beginner friendly, and that's it. Please subscribe and make this channel one of the best channel for all machine learning algorithm. When we are done with this, we actually move to the the front end cycle to see how we can visualize. I mean, like we have garden and you have plants, and see how we can make some predictions to visualize our concepts, right? Good. Thank you.